Hello, this presentation is for Construction Engineering Design Assignment 1. We are team number 5 of team leader Bae-jin Hyung and teammate Jung Sung-jae, Hwangkeum-taek, Park Sun-min, and I am a presenter, Shin Min-won. We chose to make research about Petronas Twin Towers in Malaysia this semester. This week, we prepared the basic information about Petronas Twin Towers in orders of background information, design, and construction. Then let's start with watching a short video clip about surrounding view of Petronas Twin Towers. Now, we are going to take a look at background information of Petronas Twin Towers. First, the building is located in Kuala Lumpur, the capital city of Malaysia. The usage of building is mainly office and KLCC shopping center. Its height is 451.9 meter with 88 floors and diameter is 46.2 meter. The tower was built in 1998, which took total 27 months to complete. Its main structure is outrigger system and concrete and steel are mainly used. Total gross floor area is 395,000 square meter. The tower is mainly designed by Cesar Pelli, the Argentine architect, and his associates, and structurally designed by Thompson Tomasetti, the engineering firm in US. KLCC Property Holdings Berhad was the developer of the construction. Two twin towers were respectively built by Hazama Corporation and Kukdong Engineering with Samsung C&T Corporation. People have a common culture habit of trying to build the tallest building in rituals. Many civilized worlds, from the pyramid to the Tower of Babel, have made persistent attempts to build structures that overwhelm the surroundings. The ziggurat of Mesopotamian civilization, the Chinese bell tower, and the Islamic steeple have been symbolized by religious beliefs at sky-high heights. Today, many modern skyscraper is in the same sense as ancient obelisk. Petronas Twin Tower in Malaysia is typical example of this kind of tendency. Now, we are going to look at brief business progress overview. Excavation work first began in March 1993 and took 1 year to complete. After the foundation completion, total construction took 2 years and officially became the tallest building in 1996. To look into the specific details of construction history, in early 1981, Malaysian government decided to move the Selangor Turf Club and its horse racing track from the heart of the city and to redevelop the site to meet the demands of urban and economic growth. The economic boom years of the late 1970s and 1980s made the area very attractive for developers and very congested with uncontrolled expansion. The project became a principal part of the Wawasan 2020 by the fourth Prime Minister of Malaysia as part of his government plan for Malaysian progress. Following approval of the development by the government, an international competition was organized in 1990 to select a master plan, which is an integrated mixed-use development for working, living, shopping, visiting, and enjoying for the new KLCC. The new master plan for KLCC was office buildings, retail center, hotels, residential buildings, museum, art center, and parks for 37 arts. and 63 acres were developed as public areas including 50-acre public park. In August 1991, design was selected from Shing, presented by 8 firms invited to participate in an international competition, and the winner was Cesar Pelli, the Argentine architect. The bidding process went along two nations, Korea and Japan. They expected competitive construction to reduce construction times and provide incentives to companies that have completed first, using rivalry between Korea and Japan. And there were bidding issue with Samsung C&T because they had no experience of constructing the fifth floor or higher building construction. In January 1992, the project planning has been commenced and an initial project management team, KLCCB, was established. They set budget and computerized cost management system. Excavation was first started in April 1993. Samsung was assigned to lead to build first tower, and Hazama Japan Corporation was assigned to lead to build second tower. Japan started to build the second tower 1 month earlier than Samsung. In August 1993, foundation works reached to 150 meters below ground level. There were some problems in superstructure works because in Malaysia, there were not enough steel to build the twin tower. The only source available in Malaysia was concrete. They desperately needed new formula so that normal concrete can be hard as steel. So they made progress in concrete test lab and made high-strength concrete, and it was first use of high-strength concrete in Malaysia. In 1995, they thought elevator must be installed in the twin tower so that people can access the floor in 70 seconds. They decided to put elevator on the upper and lower check. At the same time, to minimize the time taken for an elevator to travel throughout the tower. In June, skybridge of total 750 tons spanning 60 meters at 170 meters above street level was commenced. Though Japan started construction 35 days earlier, Samsung C&T poured all concrete at top floor 2 hours and 60 minutes earlier than Japan. Jacking up of pinnacles were in January 1996. The second tower built by Japan were not straight, and it bent 25 millimeters. They tried to fix this problem by bending the next 16th floor to make the tower went straight again. In 1996, the towers were certified the world's tallest buildings by the Council of Tall Buildings and Urban Habitat. Finally, opening celebration ceremony was held in 1999. To summarize main information of Petronas Twin Towers, it is 88-story building including the pinnacle, which is 451.9 meters tall. The twin towers, which are connected by sky bridge on the 41st and 42nd floors, are more than just an office building complex. The building not only emphasizes the Muslim tradition of 90 million people, but also represents Malaysia's economic growth. Now we are going to get to know about the design of the building. First, Petronas Twin Tower is mainly designed by Cesar Pelli, Argentine architect. He told that the power of the void is increased and made more explicit by the pedestrian bridge, and its supporting structure creates a portal to sky, a door to the infinite. then let's look at the design development. In order to escape the meaning of the existing skyscraper in United States and Europe, the connection between Petronas Tower, Kuala Lumpur, and Malaysia required inventory of the characteristics of traditional skyscrapers. Buildings are linked to individual areas in various ways. The shape of the Petronas Tower has its origins in the Islamic tradition of giving greater symbolic importance to geometric patterns than Western culture. Like the exterior walls of the buildings, the floor was designed with arabesque design. Its interlocking rectangles represent the shape of an octagonal star, symbolizing the power and harmony of Malaysia. However, in order to increase space efficiency, it has increased space efficiency by adding circles to each side of the rectangle. It is based on simple Islamic geometric forms of two interlocking squares, creating a shape of 8 pointed stars. Upon the 8 pointed stars are 8 superimposed semicircles, softening the inner angles. These semicircles are themselves anchored by the arcs of the main structural columns of the buildings. The semicircles were superimposed in the inner angles of the interlocked squares to create more usable floor space. For the structural design development, columns, corners, and views became important sources. Openings happen over corners. Under the wind loads, the L-shaped corner columns would experience biaxial bending and reduce frame stiffness. Columns occur mid-face and windows wrap around corners. Biaxial column bending and loss of frame stiffness is avoided, but columns would block views. So, at the final concept, columns are inset to enable a continuous, uninterrupted skin and enable clear view of the exterior from the interior. Also, this building is super tall, which is example of modern skyscrapers. The 73.5-meter stainless steel spire is the official height of the building at 451.9 meters. The spire, consisting of antenna pillars, ball decorations on the spire, and ball decorations, was constructed and assembled on top of each ornamental piece for about a month. Now I'm going to present about the construction details of Petronas Twin Tower. First is about the foundation. Before entering the design of the 88-story tower, 440 boring tests were conducted to determine the ground conditions. As a result, as you can see in the picture, due to the steep slope of the rock, the tower's location is moved 60 meters southeast, and it is constructed on a canyon-shaped underlying rock floor with a depth of 80 to 180 meters from the ground. It has excavated 104 rectangular friction piles, size of 1.2 meter by 2.8 meter in length from the base floor slab to between 40 and 150 meter. As a result of the ground investigation, it is confirmed that there are many voids in the limestone layer, and extensive grouting is conducted to fill the void of limestone before the pile construction is carried out. A 4.5-meter thick net foundation was continuously laid over 44 hours to support the upper load. They used high-strength concrete up to 80 megapascal in core wall, columns, and beams. For that kind of concrete, which has 80 megapascal strength, the size of a dice can hold the weight of 12 adult men. Following structure feature is the sky bridge. The bridge will stay well even if the two buildings move separately or twist due to earthquakes or excessive wind loads, as the complex system of rings, expansion joints, and spherical bearings were used to connect prefabricated bridges. This is because the bridge connected to the building slides in and out of the tower when strong winds blow, preventing the destruction of the building. This structural feature is all the more important because this bridge becomes an important evacuation spot in the event of a disaster in high-rise building where expensive ladder trucks cannot reach. There are some technical features exact above. The Petronas towers respond remarkably well to the tropical climate of Kuala Lumpur using several techniques. The glass cotton walls have stainless steel sunshades to diffuse the intense equatorial light. These tropical walls make a positive contribution in two ways. They minimize the heat and glare entering the building, but at the same time, they reflect the play of light and shadow, expressing the tropical environment. For the last detail, new concrete transfer technology by connecting pipes up to 380 meter high, excluding steel structures at the top of the tower without crane. The self-climbing formwork method, as well as pumps to send concrete up to the top floors through steel pipes from the ground below, meant that new floors could be added more quickly. Consequently, the entire construction process took only 3 years. And high performance concrete was first used in Malaysia construction. By this time, we tried to know basic information widely about Petronas Twin Towers. We figured out many structural and technical figures and look forward to make deeper research next week. Thank you for your listening.